Hi, and welcome to one more episode of our KIE Live Series. Today, I'm happy to have as a guest an expert on the matter of business automation, especially around Cogito in the cloud. So, before we start, I am Karina Varela, and I work for Red Hat, and I am helping facilitate this live series for you. And this live series is about the uh, a set of live streamings that we do with experts on the matter of business automation, especially in regards of the projects under the KIE umbrella, which are jBPM, Drools, Kogito, and OptaPlanner. And we try to focus mostly on the technical part of these technologies in order to bring you more knowledge and to show you how you can adopt these technologies in your real world projects. So let me bring my guest. Today I have here Ricardo Zanini, mostly known as Zanini. He's a software engineer working with on the Kogito Community project, and he's been working with software engineering since the year of 2000. It's more than, oh my God, 2 decades, Zanini. Let me bring you to stage. Welcome, Zanini. Thank you for accepting the invite to share
Hello,
your
guys.
knowledge with us.
Yeah, I'm very happy to be here. Thanks for having me, guys. And today we are going to talk about how we deploy a custom Cogito service on a Kubernetes cluster. So I'm going to share my screen so let's start working with this because we don't have too much time. Let's see
Perfect.
if I can work on
And
this.
if you have any questions, please share on the chat, and I'll make sure that I'll bring it to Zanini at the end of his presentation, okay?
Okay, can you guys see my
can
screen?
see here. Yes. Thank you,
Okay,
Zanini.
nice. Let me
Good
try to
presentation.
zoom in. Thank you, guys. So as I said, we are trying to showcase you guys a very briefly demonstration of how we can build and deploy a custom Cogito service locally, build an image and deploy it on a Kubernetes cluster. So first of all, I'd like to bring you some things about Cogito and what is this project about. So I like to say that Cogito is a tool set. It is not an SDK, not a library, not anything like that. I like to say that this is a tool set. So it is all about business automation, workflows, and all those things in this regard. And then it is all about standards. So we support BPMN, DMN, rules, and now serverless workflows as well. All of it, you can, design your own process, your own decisions, your own rules using our Visual Studio Code plugin. To create all those kind of process and decisions and all this kind of stuff that I will go through briefly in the next slides. And then you build all this stuff using Quarkus or Spring Boot on top of Cogito, and we generate a very beautiful microservice for you based on standards. No Cogito API exposed, no anything like that, and then the service is ready for a Kubernetes cluster. So it is very, straightforward for any other, SDK or toolset you see out there. But we use process, design, all this business requirement stuff to build microservices instead of just plain old Java, okay? And how this works. You basically have your process, and then you design your process. You think about your process, about your domain, your data, how they are correlated with each other, how I link customer with address, with order, and how they are tied together on a nice process, like let's say our order process. And then Cogito will take everything in there and will generate a microservice for you. Actually, some endpoints and some infrastructure code to be able to have this as a microservice, a REST microservice in your architecture, being there on a Kubernetes or whatever you want to deploy it. And about on Kubernetes and how that works. So it's basically you think about your project, you design your project. Think like, I will design this process here and there, all my data, and then I will generate an image with a Docker file that we provide for you. And then with this image being generated, being built, you can push it to a third-party registry or any registry that you have that your Kubernetes cluster can access. And you create that a Kogito runtime. That is a Kubernetes custom resource that we have, and that is you can enable it using this image that you built and deploy it on a Kogito serverless deployment. Then you see the pod running there, the deployment, all the configurations that we have, and beautifully tied together by the Kogito operator. So it is basically you design your project, you build an image, you push it, you create a custom resource based on Kogito runtime, and then deploy it using the Kogito operator. And you might think, what is an operator, right? This is the way we use to deploy a Kogito service in the cloud, in the Kubernetes. So we use an operator that is a custom Kubernetes application that I like to say. So we have plenty Kogito custom resources out there, because this is not just a Kogito service, a microservice. We have plenty of supporting services as well, like data index, management console to see your process and how they are processing and through. We have a task console, and we have a way to query for that process and see what's going on underneath, that we call that data index. And we have custom resources for all these sorts of services. But for this demo, I will just show you guys how we deploy a very simple custom Kogito service. And this custom resources we use as an input for our operator. That is this Kubernetes application that has a small controller inside. We use the custom resource, we use the controller, and then we manage and we create Kubernetes resources that will be your application being deployed out there. If you know Kubernetes for the old style, before operators, we used to have like templates, like static YAML files, lots of them. Like if I want to deploy a service, I would create a deployment. I would configure the application with a config map. I used to have, I need a storage, so I would create a persistent volume. So all this kind of stuff, I need to create by hand, all the YAML files, and that was very cumbersome. And this is a static deployment. If you take a YAML file, you say Kubernetes deploy it, okay, create those resources in there. And if you have any changes, like an update or something that is not working on, you have to manually go there in your Kubernetes cluster and see what's going on and trying to figure out the way. Using the operator, on the other hand, you can actually delegate all this kind of administrative infrastructure tasks to the operator. So the operator will deploy for you, will create all those resources for you, and will make sure that the deployment will work. The deployment, it is there working, and everything is on the page. And there's this link here. I think that Karina will share with you guys the presentation after this live. And this topic here in the Red Hat website, it is a very nice article about what is Kubernetes operator and what and there's lots of details in this article, and it's very good to see it. Okay, and after I create my project, I create the Kogito custom resources, I install that using the Kogito operator, and what's going on underneath. So on this orange square that you're seeing here in the presentation, you can see that there's some Kubernetes resources here that the operator creates for you. First of all, it is a deployment, that we created. With lots of information about the service itself, like the image that you're using. The Kubernetes will pull that image from the registry, and we'll create this deployment, a service for you to expose the service afterwards using your preferred approach, like an ingress, for instance. We create a config map to handle all the protobuf files that the Kogito services create. Like we have this way of persisting the process in InfiniSpan, for example. And to do that, we need a protobuf, to serialize the domain data on InfiniSpan. And the operator will create this protobuf and will generate this, and will store this protobuf files in the data index. We'll attach this volume in the data index so you can query your data in our data index service after that. And also we have a config map for the application properties. So you can override any information about your application during runtime, during deployment time. You can open this config map and add some, for instance, log level. You can change the log level for the application. You can change on how it connects to a Kafka instance, for example. You can, do whatever application property that you wish to do in this config map that will be replicated to your application. After you change something in the config map, the operator will redeploy your application to the new configuration. That is pretty cool. And for this demo, actually, what is more or less the infrastructure that we are going to need? So for locally installations and local try, I'd say that you could have our Minikube or Kind. I really like Kind. It is very lightweight, and you can install the operator there and try it. But for this demo, I'm going to use Minikube. And of course, if you have admin access or any Kubernetes cluster, you can also use it. kubectl, that is the command line to interact with the Kubernetes cluster. Podman or Docker, but please use Podman to build your images. Java 11, maybe Entry 6, and Git as usual. But if you're a Java developer, the chances are that you have this all this stuff installed locally in your computer. And Visual Studio Code, because we have this very nice plugin to edit all the diagrams, the BPM file in there. That is nice to have, and I also love, because all we need is level, right? So let's start showing some stuff in here in our demo. Let's say explore a little bit of the project that we are going to deploy it. So this is the process business rule Quarkus. That is the project that we are trying to build in here and trying to deploy it on a Kubernetes instance. So this is our process, okay? This is in the resources folder. You can see the process here. You can edit, you can do whatever you want using the editor. I won't change anything because this is a demo and things can get ugly if I change too much. But it is basically a very simple process that is start, run some rules, and depending on the output of this rule, we'll take this path or you take this other path, okay? If it is a children, we are going to have this user task here for handling children. If it is not, I'm just going to end my process. And how do I evaluate this rule here? It is a simple Drools rule. So if your age is above 18, you're considered an adult. And that's it. It is basically the process. So if you're an adult, we are going to end in this path. If you're not, we're going to handle you with care because you're children. And then what is going on underneath? When I do like this, Quarkus dev, I'm going to generate all the code, the source files, and everything for this process of ours. And we will start the application locally. So we can go in here. Go ahead.
I'm sorry for interrupting you. Just remember to increase the font size on the terminal next time you are going to work on it. Thank you.
Can you guys see now?
Yeah, it's better. Thank you.
Oh, okay, no problem. Okay, so this is the application, okay, running locally on 8080 port, and this is the Swagger API that we can actually play around a little bit with this. But instead, I'm going to curl the part. Let me see if I have in my cache. Actually, I have it is localhost. So I'm sending this curl in the person's endpoint with John that is age 20, and you say he's adult. It is true, okay? So let's pretend that this is in my case 18. It is not being adult. In my case 21, it is to be adult. So notice that this is the application is running. I'm not changing anything, so I'm going here in the rule file, and I would say, oh, now you need to be 21 to be considered an adult. And if I send this again, Quarkus will regenerate everything else and will say, oh, John 20 is not adult anymore. So this is a pretty cool thing, you know. It is just a demo, of course. It is pretty simple. I'm just changing one variable. But think, if you are developing something for huge bank system that you have like tons of taxes, you know, and numbers and equations and all of this stuff, you won't have that on your Java code. You won't, you know, this is impractical to have all these business requirements, all these business rules inside your Java code. It is maybe, you know, a pretty nice thing to have this like this in the, you know, in a form of a rule or a decision, for instance. And having this as a process, what is the advantage of having this as a process? I can print this, or I can send this for to a business person and say, oh, this is the process. This is how the microservice is handling this specific use case. And anyone in the company can understand that. They can say, oh, okay, I understand that this is there's a start process in here, and I'm evaluating something, and then depending on the output of this process, I will this task I will be going here, or I'll be going in there, and then you can discuss based on that. It is much simpler, you know, and you can take people closer than with you, like, hey, business analyst, this is what I have. This is what I'm trying to build. This is what the microservice will react upon. This is the process behind it. So it is pretty cool to have this kind of communication with others, because, you know, the key of success, it is just, you know, having a good communication with people. And to be able to do that, you can have this. You can have, you know, lots of processes, and you can, you know, orchestrate them. You can call sub-process and create other Kogito services and then orchestrate them in a Kubernetes cluster. And that's pretty cool. So let's stop our application, and let's pretend that we now wish to deploy it on a Kubernetes cluster. So for instance, I'm going to compile all the application again. I'm going to generate the jar files, the jar file that is needed for us to create our Docker image to be deployed on a Kubernetes cluster. So this can take a while. So I think it would be nice to have to listen to music while we are building this stuff. Things are not going well here. What is happening? Oh yeah, of course, I changed the rule. Let's go back there. The test is expecting an 18%. I'm changing for a 20. Let's change that back again. Okay, this is nice because we can, you know, keep listening to this good music. So let's continue with our app here. Yeah, we've finished. So if you see in the target directory, you're going to see that we have some jar files here. And the most important file is the Quarkus runner jar file. And then you can ask yourself, wait, how we have this endpoint here? Actually, we generated everything in the directory: target, generated sources, key, person's resources. So this is a Quarkus JAX RS resource file with path point to persons. Like you said, when you saw when I curl this endpoint, we post to this function here, to this method here, and we started a process instance. That's how the magic is going. And as you see, we just handle your domain, the person's model, your domain. Is not something like awkward API nor anything like that. And all these files are generated and packaged in this Quarkus runner jar file here. And hopefully I have the build command here. That is, I'm using Podman. I'm going to tag this image using this name. Quarkus is my namespace and the name of the project. And I'm going to use this Docker file here that we provide for you. Okay, and let's build the image here. This is pretty cool and quick, and the image is built. So you can take a look on the image that we have. Oh, that's maybe 8 seconds ago, so we just built this image. And we can actually, oh, sorry, what's this? Stop. We can run the image as well. I'm running in the port 8080, so we can curl. Let me see. Yeah, same thing that we was trying with the example locally. We can do with the image as well, because I'm forwarding the port to my local 8080 port in here, and you see that's everything that we need. Okay, and the next step would be like to push this image to Quake. I won't push it because it will take a long time and it will take all my bandwidth. Since I'm streaming live, I'm worried about my internet connection. So like that food show that the guy have the cake already baked. I already have my cluster ready to receive my stuff there. So let's see. I'm going to get all the pods on my Kogito namespace, and you can see that we have the Kogito operator already installed on my cluster. And you might think, oh, how can I supposed to install an operator on my cluster? So there is a lots of options. We have the Kogito install command. I'm not sure if this is working because I changed lots of things in my path, but you can install the operator using our Kogito CLI. So just type Kogito install operator and you have it installed in your namespace. This is pretty cool. Or you can download the source code for the operator from our GitHub page. That is this one in here. Oh, sorry, not my fork. And when you have plenty of releases, and the last one is 013. Oh, you can actually download the CLI for your platform here, or you can download the source code and use our install script to install the operator in your cluster as well. So this is pretty cool thing. Let's pretend that we already have the operator installed on your machine, and now I wish to actually install the application, my application that I just built, the image that I just built. For that, we have in the operator directory in the example. This example is on GitHub, and I will send the link after the live. There is this Kogito runtime, the custom resource that I told you guys during the presentation. So here's the namespace and the the registry that I'm going to pull the image that I just pushed to there, and that's it. And just say to the operator, hey, deploy this runtime for me. And how do I do that? Well, I can apply a file like operator, the name of the file, and that's it. And when I get the pods, you're going to see that the operator already started to create my application. That is everything in there. So if I get deployment, you're going to see my application deployment here. Or if I can get the configuration files, you can see here as well. Let's describe this config map for you guys to see what is going on here, what is going underneath. So this is an application properties, and by default, the operator will add this property for you. But you can edit this config map and add any information that you need. After saving it, the operator will respin your deployment, and we will have a new pod in there with this new configuration. So our service is working, and let's see the logs if it is in there, if everything is working out. Yeah, everything is working, it seems. And the next question is how do I expose this? Normally, I like to use an Nginx ingress when I'm working on Minikube, but unfortunately, there's a bug on Kubernetes right now, Minikube right now, and like 25 years ago. So this is an open issue on Minikube side. And we can actually create the Nginx ingress on Minikube for now. But we have options. So that's the important thing, right? We can use node port to expose our service. So I'm going to create a new service that I like to call it Kogito Exposed. So you see the name here of the service. I'm going to expose this deployment that I have in here. And that's it. I have the new service pointing to the created using a node port, and I can take this webhole with a new. Let me see, Minikube. Let me take the webhole here. So we just say, oh, I wish to see the webhole, the external webhole for this service that I just exposed. So Minikube has this nice application that you can see here. And we can curl the application as we curl locally. We can use this endpoint instead. That is the external endpoint. And hopefully will work. Come on. Okay. So John, 20 years, is adult. We can change that, like say, 10 years. Is adult, false. So that's how what I like to show to you guys on how to deploy and do some basic stuff on Minikube side, and how, for instance, how to deploy it, how to build the image, how to push the image, how to deploy it using the Kogito Operator, and how to expose your service using Minikube locally. So you can try and see your application deployed in there. So I think that we finished on time. I don't know, Karina, do we have any questions, or you?
Yeah, we have a couple of questions here, and I'm sorry about the back noise here. I just can't deal. It's home office. That's how it rolls. So we have a question from Vibeup. He says, like, why should we use the Kogito operator? We could deploy our Kogito application using simple Kubernetes deployment files. What benefit Kogito operator brings to us?
Yeah, that's a nice question. That's a very interesting question, actually. Yeah, you can use static files to deploy your application, but like I said in the beginning, using static files would cause you to to have to go there and keeping up to date every time. So, and if you wish to use, like, for instance, data index or management console data supporting services that we have, the Kogito Operator will tie everything together. We'll tie the data index with your service. We will inject the warehouse for data index in the Kogito service. So your Kogito service can send messages to data index, and they can, actually work together beautifully. And also, we deploy Kafka in Finispan for you as well. And if your service needs persistence, or if your service needs events handling, we can do everything in there for you as well. You won't have all the trouble to create the static files, to tie things together, to figure out which environment variable I need to inject in the Kogito service, and so on and so forth. And I just used the kubectl command line here with a static Kogito runtime file. But instead of that, I could have used the Kogito CLI as well. So we have like a CLI tool that you can just go Kogito deploy, this is my image, and that's it. It very simplifies your workflow, your development workflow.
Nice. Yeah, I get it. There's another one still regarding the operator. So why is it looks tightly bound to Infinispan? Is it that tightly bound to Infinispan, and why? Because Vaibhav, for example, he's using Redis, and all the developers are already familiar with it. So do they need to learn Infinispan in order to work with Kogito?
No, actually, the Infinispan integration that we have today, Infinispan Kafka integration that we have today, it is basically meant to, to have a quick startup for developers to use locally. So they won't care about deploying Infinispan or Kafka on their environment. They just, say to the operator, "Wow, I wish to use Infinispan." That's it. But if you use another type of persistence, we are supporting right now, if I'm not wrong, MongoDB as well. And you can create your MongoDB infrastructure and say to the Kogito system, Kogito Operator, "Oh, hey, I'm using MongoDB. I'm not using Mongo Infinispan. Here's my credentials," and that's it. We configure your application to use this another persistent store. But for Redis, we don't have persistent support for Redis right now on the Kogito runtime side. Because one thing it is the operator, the other thing is the Kogito runtime services itself, our engine. So for the persistence layer, we need some engineering work in there. So to allow all this kind of persistence side, because like I said in the protobuf slide. We need to serialize in a certain way the domain data to have it persisted in this environment. Like in Finispan, we use protobuf. In MongoDB, we may use another thing. For Redis, we might also look into another thing. But as soon as we have the support for Redis, you should be okay if you just configure the configuration map that the operator deployed for you with the information about Redis and where is there and how the application can reach it and connect to it, and should work.
Thank you, Zanini. And we saw that you used Quarka's dev feature that has the live reload, and this triggered another question. So every time you need to change a BPMN file, for example, do you need to release a new version of the application? Does only the developer, because in this situation, only the developer would be able to maintain these BPMN files. The Vaibhav is currently using an engine that allows him to change it in runtime. Therefore, his question.
Okay, yeah. Only during the development you can change the file and make use of the development of the live reload feature on Quarkus. When you're developing, when you deploy the service and you realize that you need some changes in your process. Oh, this is wrong. I need to change to another version. Yeah, you're going to need to build it again. Luckily, we have this incremental build feature. This is just for OpenShift, but we are actually working on Kubernetes as well. To be able to do that on Kubernetes as well. But on OpenShift, you have incremental builds. That is, you can change just one little thing and then upload the little thing, and the build will roll out again. But all the libraries that you need, everything that you need to deploy and to have that application up and running, you'll be able to do that, in a short time. But yeah, you have to do it because it is a change in your code. Because the approach that we are taking right now, it is not runtime oriented. We do not, use reflections nor anything like in this regard. We take lots of features on build time as well. So we need to read your resource file, being a BPMN, a DMN, a serverless workflow, whatever file that we support. We need to read that, and we need to build all the bits, all the code based on that file, and to generate the application. On one hand, we have this very nice feature to short the time for things to run. We won't take too much time in runtime, compile time to figure out or to validate things. We are just using that the build time to take advantage of that. So to have that, unfortunately, if you change something, you have to build it again. But thanks to the incremental build, you can short this time a lot. Because it is a new version of the application. That is how we understand that. This is a new version of the application. That's why you're going to need to build it again and deploy it again.
And even though we are building it on the technical side, it can be transparent for the business users. So for example, if the person goes to dmn or bpmn.new URLs, the person can import this file or edit it straight on GitHub, for example, and this repo, and then just upload it back to the repo. Yep. And once this repo gets updated, then technically we will trigger a new build, because that's how we...
Exactly. Exactly. We have webhooks on builds that, every time a change happens on your Git repository, the change will trigger another build, and in 3 minutes you see another version of your application being deployed on a Kubernetes cluster. So that's the whole workflow.
I like to see this as like, if you compare it to a Java project, you don't go straight into a production environment and change the .class file. So that sounds weird for me. Thank you, Zanini.
Yeah, for instance, the last example, you have this very complex account application that, the tax in the rule is like 10%. And from the one day to another, they change that for 11%, because government does that. So you can just go there in your rule file and change to 11%, and that's it. It will work right away, and you go through your CI and you build all the application again. But and that's it. You won't have to realize lots of stuff and figure out where is in the code that you have that rule fixed, and which constant you have to change for that text to work, or not anything in this regard. So that amplifies the development experience a lot.
Thank you, Zanini. Thank you for the great explanation. We learned a lot from you today. I expect to have you here again, sharing more knowledge about Knative, for example, because I know you have some stories on there.
Hopefully we will bring something on this regard as well.
Nice. Thank you, Zanini. Have a nice day.
Thank you, guys. Thank you. See you. Bye.
Thank you for staying here until now. And now you hope we can meet on the next KIE Live, where we will be talking about more business automation tips for you. Okay? Have a nice day.